Hello, my name is Reza Saadati. I'm a PhD student in the CS program at WPI. My research is multimodal neural network for chronic wound decision support. Many Americans suffers from chronic wounds, that is from that they might suffer from diabetes or pressure ulcer or other kind of wounds. And chronic wounds treatments cost too much to health system to the US, and also many people don't have access to wound specialists. To deal with this problem, in this research we provided a multimodal neural network that help people that suffer from chronic wounds to have more standardized decision support. Assume somebody lives in the remote area and they don't have access to specialist wounds, and for example, but usually they do have access to a nurse. A nurse can go to their home and see that patient, and they can take a picture from the wound condition of the patient and also write some clinical notes. When they do have these two input data, they can pass it to our proposed model and get one of these three decisions. The first one, continue current treatment. The next one is they need to go and see a specialist and change the treatment, but there is no urgency. And the last one is urgent referral to the doctor. Our data set is quite small. We have only about 200 images that are labeled, and clinical notes are provided by two wound experts at UMass Memorial. Here is three examples of our data set. This is an example for decision one that they can continue current treatment. An image of the wound is provided, and also related clinical notes are provided here. And for decision 2 and decision 3, we also provided one example. And in the next section, I'm talking about model structure that we have for to deal with this problem. As I mentioned, we have two different modalities. The first modality is image. The second one is text. We need some neural network to extract features from image and text, and then we need a model to combine these two extracted features to each other and do classification for extracted features from both image and text. At the end, as I mentioned earlier, our model will provide one decision, that is continued treatment, non-urgent referral, or urgent referral. Now, as I show you the pipeline of the model, we are going and talking a little more in detail about each component. The first component is image component. We need a neural network for extracting features from images. And as I mentioned, we have only 200 images. That for training, deep neural network is a little small size. To deal with this problem, we use transfer learning. In transfer learning, our base model is first pre-trained on the big size of data, like ImageNet, that is millions of data, and then we fine-tune the last few layers with our 200 images and make it proper for our special case. We also use some classical augmentation to make our 200 images to about 800 to fine-tune the model. The next important part of the model is text feature extraction. This part, to extract features of text, we use newer model like attention-based model like GPT and BERT model that are used widely these days. And there are some special some medical BERT versions that we use for this specific task that is related to our task. We use BioBERT and clinical BERT because they are pre-trained on clinical text. The last part, and also heart of my model, is how we want to combine text and image feature to each other. We use intermediate fusion model. Assume this is our image, the green one is image, and the blue one is the text. We are passing to those two models that I described above. Then we have those features. By using intermediate fusion, we're combining extracted features here and passing to the classifier. That can be, in our case, for example, multi-layer perceptron or SVM. Then we are doing a classifier. After classify and see the label, we can backpropagate error to all parts of the model and train the model to reach the better result. In the results section, I'm showing you the results that we reach for 3 different types of models. The first one, image-only models. The second one is text-only models, and the last one is multimodal that is proposed by our work. As you see also here, I provided our data set here for different labels. As you can see, for referral urgent, we have much more data. For first and second decision, we have less data. Our data is unbalanced, and it makes solving the problem even harder. We have a small size of data and also imbalanced data. We tried by using augmentation solve a little this problem, but still it's a tricky one. As we expected, multimodal algorithm that is proposed by us reached the best accuracy of 73% and beats all other models. We expect to reach this kind of accuracy because we are using features from both image and text. And as in image, we reach 64, and for text-only model, we reach 71. To summarize, we combine image and text to benefit from both modalities in our special example, a special problem. As we only have 205 images and related text, we needed to do some augmentation to make our data set larger. We also we plan in the future, we plan to use much more newer model and state-of-the-art image models like vision transformer, and also we plan to use and make a comparison between built-in multimodals like Clip and Gemini, and make a comparison with our model. At the end, I need to thank Professor Agu for giving me the opportunity to work on this interesting project, and also for all of his advice. Thanks.